Good morning, guys. This is Anjani Kumar, Electrical Department, Newlands Group of Institutions. I'm continuing my lecture on instrumentation subject for final year electrical students. In the last class, we discussed about a brief introduction of instrumentation. What are the chapters? What are the contents that we are going to deal? We discussed in the last class. From today onwards, so I'm going to start my chapter 1, it's the first unit. In the first unit, I'm going to discuss about today measuring system and different types of instrument we'll discuss in this session. So first, what is a measuring system? So before going to measuring system, first you have to know what is a measurement. So what is a measurement? A measurement is the process to find the unknown quantity which is compared to the standard quantity and result in terms of standard quantity. Listen, unknown quantity in terms of standard quantity and the result can be expressed in terms of standard quantity. So this is the definition of a measurement. See, for example, I have a water. I don't know how much quantity of water, so that is my unknown quantity. So what is the standard quantity? You know the standard quantities: liter, half liter, kg, 500 grams. All these things are standard quantities, right? I have a 1 liter mug or 1 liter bottle. Unknown quantity is compared to the standard quantity. That means you have to put that water into that bottle. 1 liter bottle is there in a standard quantity. After that, you will get the result in terms of standard quantity. So you know that result: 0.5 liters, 0.8 liters. You will get the unknown quantity. See, got the definition. I'll clearly explain the definition once again. So measurement is the process at which unknown quantity compared in terms of standard quantity and result can be expressed in terms of standard quantity. Here unknown quantity enti? Water. I don't know the quantity of water. You know the standard quantities. You just compare. You get the result: 0.8 liters. That is nothing but standard quantity. So that is a measurement. So if you want to measure anything, you require an instrument. So measurement plus instrument, we can call it as a measuring system. So what is a measuring system? So measuring system means it consists of a measurement plus instrument. So both clubbed together, we can call it as a measuring system. So if you want to measure, definitely we require an instrument. So different types of instruments are there in electrical systems. So what are the instruments? We discuss. Based on a methodology, what are the methods that are going to be used to measure the system? Instruments are classified into two types. These are very, very important. So based on a methodology, the instruments are classified into two types. The first one is absolute instruments or primary instruments. Listen, first one is absolute instrument or primary instruments. Second one is secondary instruments. Alright, first we'll discuss about what is absolute instruments. So what is absolute instruments? Absolute instruments which measures the unknown quantity in terms of physical constant of that instruments, right? Which measures the unknown quantity in terms of physical constants of that instrument. See, if you want to measure the power, how the process will be means, first with this instrument you just conduct the test. After that you will get the result. These results are directly substituted in the formulas. After that we will get the result. You get the correct measurements with the help of these absolute instruments. You won't get directly the result. See, first if you want to find the power, conduct the test for find out the voltage, conduct the test for find out the current. You know the formula, P is equal to VI. You substitute V, you substitute I, and multiply, you'll get the power. So these type of instrument, you won't get directly apply, you won't get the result, how much power it is. So these type of instruments are called as absolute instruments. These instrument doesn't have any rotating parts, there is no pointer, there is no spindle, doesn't have any mechanical movements, so the losses will be reduces. Because you are applying a formula means it gives the accurate result, so definitely these type of instruments will give the accurate result, right? So in practically we won't use these type of instrument. Why? Because you are going to do more number of steps, right, in order to get the result. But normally we don't go for these type of instrument in real life, right? Basically these type of instruments that we can use in our laboratories, research and development laboratories, because they require perfect results, they require correct results in order to publish any paper. So the statement should be true. So that's why in a research laboratory, so we are going to use these type of instruments. So what are these absolute instruments? In our daily life, we have only 4 absolute instruments, remaining all our secondary instruments. What are the 4 absolute instruments? The first one is a tangent galvanometer. So tangent galvanometer is an absolute instrument which is used to measure the current or voltage. And second one is a Lorentz meter, which is used to measure the resistance. The second one is a Lorentz meter. And third one is a absolute electrostatic meter, which is used to find out the voltage. And the fourth one is a Rayleigh's current meter, which is used to find out the current. These 4 are absolute instrument in our life. Remaining all are secondary instruments. So if you get definitely you'll get short answer questions. What are the absolute instruments among the following? This is a great question. They'll give the options. From that options you will easily find out which one is absolute instrument, which one is a secondary instrument. We'll see. So let me explain once again what is absolute instruments. So absolute instruments which measures the unknown quantity in terms of physical constants of the instruments. Physical constants means those are constants. So you have to find, you have to find. These are the constants you have to find. Put in a formula, I'll get the result. You won't get directly the result. The help of absolute instruments, which we can also call it as a primary instruments. Losses are more accurate, not used in daily life. So research laboratories, we are going to use these type of instruments. What are these? Tangent galvanometer, Rayleigh's current meter, and after that absolute electrostatic meter, and the last one is a Lorentz meter. Right? And remaining all are secondary instruments. I'll go for a secondary instruments. So what is the definition of secondary instruments? So secondary instruments are the instruments which measures the unknown quantity, under the measurements itself. Right? Which measures the unknown quantity under the measurement itself. But suppose if you want to find out the power, you will directly connect the instrument, you will get directly the power, right? If you want to find out the frequency, you will directly apply the instrument, you will get the frequency. No need to calculate, no need to conduct the test, no need to find out the voltage, find out the current. You will directly apply the unknown quantity to the instrument, you will directly get. These type of instruments are secondary instruments. Parameters under measurements itself. So what is the definition of secondary instruments? Secondary instruments are instruments which find out the unknown quantity, the parameters under its measurements. అంటే నువ్వు మెజర్మెంట్ చేసేటప్పుడు వచ్చే వాల్యూసే the final results anamata. No need to wait for all the calculations, right. In this you have a mechanical moment, pointer is there now for moving in order to detect the power. So definitely the mechanical moment is there, the losses will be there. This is not accurate, some errors you will get at the time of find out the required value, right. Definitely these type of instruments we are using in our real life, right. So what are the instruments? You know that current meter, voltmeter, right, power factor meter, watt meter. It will directly give the result. If you want to find out the frequency of something, some signal, you just give to the instrument frequency meter. From directly you will get the result. This is a 50 hertz, this is a 25 hertz. Directly, no need to apply any formula, no need to conduct any tests like primary instruments. So these type of instruments are called secondary instruments. I think you understand. So what depends on methodology. There are two types of instruments. First instrument is the primary instruments or absolute instruments. There are 4 absolute instruments. After the secondary instruments, parameters under measurements itself will get the result. These type of instruments called secondary instruments. Current meter, voltmeter, power factor meter, watt meter, all these things or secondary. So you are going to discuss about secondary instruments only. And again, secondary instruments are classified into different types. The first classification is based on end measurement. Based on end measurement, the secondary instruments are classified into 2 types. Because definitely secondary instrument means you will get directly result, but the type of getting directly result, they are further classified. You know all these things, right? Based on end measurements, the secondary instruments are classified into 2 types. The first one is a deflection type. First one is a deflecting type, and the second one is a null type deflection, right? First one is a deflecting type. So what is a deflection type? So if you know the unknown quantity, by deflecting the pointer from 0 to something, I have a scale, right? I have a scale and I have a pointer. If you want to find out the unknown quantity, you just apply this instrument. My pointer starts moving. The pointer record agite, that's my result. So this is called a deflecting type instruments. Alright? Deflecting means pointer is there, pointer starts moving over the scale. When the pointer stops, that will make a result. Right? That is a deflecting type instruments. The pointer starts moving means it requires some energy. We are getting some power loss. Definitely there will be a losses. Mechanical movement is there, definitely there will be a losses. Right? What are the deflecting type instruments? Voltmeter, ammeter. In a laboratory that we are using voltmeter, ammeter, wattmeter, speed meter. All these things are speedometer, all these things are deflecting type instruments. And the second one, which is more accurate? This is accurate because some losses is there. That's why this is not that much accurate, but we are using nowadays, right? And the second one is null type instruments. What is a null type instruments? The instrument which finds the unknown quantity by null deflection or a 0 deflection. Bridges. When the bridge is balanced, zero deflection happen. When the 0 deflection happen, we will get the result, right? Null deflection means a 0 deflection, right? On galvanometer is there AC bridges or DC bridges. When the bridge is balanced, the galvanometer reads 0 deflection. So these type of instruments called null type instruments, right? These null type instruments, that is somewhat accurate when compared to that pointer deflection type instruments. So what are the null type instruments? Somewhat accurate. What are the null type instruments? Potentiometers, AC/DC potentiometers, and the second one is AC and DC bridges. These are using null type deflection instruments. And based on end measurements, what are the different types of instrument? Secondary instruments, there's a deflecting type and null type. Deflecting type means pointer starts moving from 0 to unknown quantity positions. When the pointer stops, that will give the total result of unknown quantity. Which one is more accurate? Null deflection is more accurate when compared to the deflecting. Null deflection is more accurate, right? So what are the which one is having more losses when compared? More losses because the deflecting type is getting more losses because the pointer starts moving. Power consumption, more losses, more power consumption, mechanical losses is there. So these are end measurements. You know that another way, based on mode of operation, there are two types of secondary instruments. Based on end measurements, two types: deflection type and null type. Based on mode of operation, there are two types of instruments: analog instruments, digital instruments. So what is analog instruments? These instruments measure the unknown quantity by varying the time, continuously varying the time. Sinusoidal signal, which is analog signal, right, which is continuously varying with respect to time. Analog voltmeter, analog ammeter, analog multimeter, all these things will get under this category. And the second one is digital meter. Discrete with time. Certain time will get the result, and another time will get the result. So discrete with respect to time. So what are the digital type meters? Digital voltmeter, digital ammeter, digital multimeter will get accurate result. Is there any mechanical moment? There is no mechanical moment. Right? High sensitivity. Right? These are advantages of this. Nowadays we are using digital meters also. Right? Which one is more advantageous? Digital. Which one is more losses? Analog signal. Analog instruments are more losses when compared to the digital meters. Right? Based on application also, there are two types in secondary instruments. Those are portable instruments. Right? Portable instruments means wall fixtures. With that, portable means based on application, we are having two types of secondary instruments. Those are panel mounted instruments and portable instruments. So what is panel mounted instruments? Panel mounted instruments means we directly fix that instrument to the wall itself. From that we'll get unknown quantity. And portable instruments means we can carry the instruments wherever. If you want to find out any unknown quantity anywhere, you can carry that instruments. Those type of instruments are portable instruments. And the most important secondary instruments are based on measurement. So based on measurement, you have three types of instruments. So what are the three types? Indicating type instruments, right? Recording type instruments, and integrating type instruments. These three instruments, if you want to listen carefully, based on measurements or based on operation, based on measurement of unknown quantity, the secondary type of instruments are three types. The first one is indicating type instrument, second one is recording type instruments, third one is integrating type instruments. So what is indicating type instruments? These type of instrument which measures the unknown quantity instantaneously. When switch on the supply, the pointer will move and directly goes to that unknown quantity position, instantaneous position. Right? I'll get directly instantaneous value. Right? Indicating type instruments means it gives instantaneous value of that instrument. Instantaneous value of unknown quantity at the time of measurement. Right? So what are that real life? We are using voltmeter. Switch on the supply, directly the pointer will move. I'll give the instantaneous result. Ammeter, voltmeter, wattmeter, definitely these are giving instantaneous results. So that's why we can call it as these type of instruments these are secondary instruments. Because why secondary instruments? Directly you are getting result. No need to go for any formulas, no need to go for any tests and all these things. Right? That's why these are indicating type instruments. And second one is recording type instruments. So these type of instruments which records the past and previous values also for a particular period of time, right? Which records past and present value for a particular period of time. You know that ECG. So the ECG is a recording type instrument. It's also an instrument. It can record for a particular time. Okay, that person in few days back having signals like this, and today's the signals is like this. It can store the information. X-ray, X-ray data recorders, right? Galvanometric recorders, and all these things comes under category of recording type instruments. And the final one is integrating type instruments. So what are the integrating type instruments? So integrating type instruments also instruments which can give some or total electric power consumed at a particular time. Integral means over a period of time. So integral instruments means over a period of time how much energy consumed for a particular house or a particular load, how much energy consumed for a particular period. It gives integrating type instruments like energy meter. In measurements you studied about energy meters. Energy meter is an integrating type instruments. Over a particular period of time, total sum of total electrical power consumed for a particular person or a particular house or a particular load. Right? What are that integrating type instruments? Alright, energy meter, watt hour meters, amperes hour meter. So these are integrating type instruments. Hour, watt hour, energy. And if energy came, definitely those are integrating type instruments. Alright, based on operation, the principle of operation. The instruments are PMMC, permanent magnetic moving coil instruments, moving iron instruments, electrodynamometer type instruments, electrostatic instruments, right? All these things, these are principle of operation, right? These are secondary instruments. Several instruments is there: mechanical instruments, electrical instruments, right? Hydraulic instruments. These are several instruments. We don't go for all these things. So basically, what are the different types? Based on methodology, there are two types of instruments: absolute instrument and secondary instruments. Absolute instruments we can call it as a primary instruments. What are the absolute instruments? Parameter, particular constant. Constants depends on constants of instruments, right? So what are the primary instruments? Primary instruments, you have to conduct the test and put some values to some formulas. After that, you'll get the result. These are more accurate, right? And we won't use these type of instrument in our real life. Research laboratories, we are going to use different types of primary and second. What is the secondary constant? Directly we'll get the parameters under measurements itself. We'll get the result. Like voltmeter, ammeter, because mechanical movement is there, so that's why losses is there. Not that much accurate also. And all the secondary instruments nowadays we are using. Alright, based on end user measurements, secondary instruments are classified into different types. Based on end measurements, the secondary instruments are classified into deflection type, null type. Deflecting type means the pointer. When you apply unknown signal to that instrument, the pointer starts moving. Ekkadaithe pointer agipothado, that may result. That is nothing but deflecting a pointer from zero position. What is the null type instruments means? It gives unknown quantity. When null deflection or a zero deflection happening in the system, will get the result. So what are that null deflection means? AC bridges, DC bridges, potentiometer, all these things. After that, based on operation, based on measurements, based on principle of operation, PMMC, MI, moving iron instrument, electrostatic instrument, all these things based on principle of operation. Based on application, portable instruments is there, wall mounted instruments, portable instrument is thing based on application. Based on measurements, what are the instruments? Indicating type instrument, recording type instrument, integrating type instruments. Integrating type instrument, it gives instantaneous value at the time of finding the unknown quantity. Recording type instrument, it records present and previous values also. Integrating type instruments over a period of time, how much energy consumed in a particular load or a particular system, you can call it as an integrating type instrument. So what are the integrating type instruments? Energy meter, watt hour meters, ampere hour meters. These are comes under category of integrating type instruments. So this is about all these instruments which are used in a measuring system. So what is the definition of a measuring system? So measuring system consists of measurement and instrumentation. Both clubbed together, we can call it as a measuring system. So what is a measurement? Measurement is the process. Unknown quantity can be compared to the standard quantity and will get the result in terms of standard quantity. See, you know the definition and what are the different types of instrument we discussed, right? This is about measuring system. In the next class, we'll discuss about what are the characteristics of instruments. There are two types of characteristics of instruments: static characteristics, dynamic characteristics. We'll discuss about briefly in detail. No doubt about that. Definitely you should understand if you follow my videos. Definitely you'll understand the concepts. If you have any doubts regarding this first topic, you can call me and ask me whatever the doubt. Definitely I'll clarify, and definitely you should follow the videos. Right? Stay home, stay safe. Thank you very much.